Now, our unit 1 is almost complete. Let's do the exercise questions, or you can call it, we call topicals. Topicals are basically those questions that come in our exam. You can also call them an exam style questions. So let's begin it, and let's go through them very quickly, as we have already studied all of these topics. Okay, now we have these are basically 9 questions that we are 11 questions that we are going to do. The first question, it is basically a case is given. Jolene displays videos on her website. She uses lossy compression to reduce the file size. Describe how lossy compression reduces the file size of the videos. Okay, let's do the first question. How lossy compression reduces the file size of the videos. What it does, lossy compression reduces file size by permanently removing certain data like pixels, like sound quality, that is deemed less important or noticeable to human perception. For example, the pixels of the images, they removed such pixels that do not affect much of the image quality, so that are not very visible to the human eye. So this is how lossy compression works. In the case of videos, this may include eliminating subtle color variations that are not necessarily easily detected by human eye, discarding high frequency sounds or visual details that have minimal impact or perceived quality on perceived quality. Okay, any voice frequency that has minimum impact on the quality, or reducing resolution or frame rate, which decreases the overall amount of data being stored. Okay, we can also reduce the resolution, and that decreases the overall amount of data. So these are basically 3 methods for lossy compression. First, it has said that it removes those details that are not visible to human eye, and it may remove those voice details that are not detectable by human ear, or it may remove the resolution. It all depends on the compression you are using in lossy. Okay, now the part B, why Jolene would use lossy rather than lossless compression for videos. In lossy compression, there are 2 benefits. We can have smaller file size and faster streaming. Lossy compression results in significantly smaller file sizes, which reduces bandwidth usage and storage costs when streaming or hosting videos online. And it causes a faster streaming, obviously, because smaller file size gets uploaded easily, and the faster streaming and the reduced file size allows for faster loading times and smoother streaming experiences, which is important for users with slow internet connections, because we have to reach to the more number of users. So obviously, for users with slow internet, they would also want to see the video smoothly. For them, what Jolene is using smaller file sizes. It is using lossy file compression. Lossy file compression, it does what? It permanently reduces the file size. Okay, and next we have another question, that is a camera detector. This question is related to calculation of the file size of the image or of the sound file size, whichever file it is. Now the first, a camera detector has an area of 4096 by, you can call it resolution as well, has an area of 4096 by 2048 and uses a color depth of 16. Calculate the size of an image taken by this camera. Okay, we have to calculate that in megabytes, it has asked us. So in order, we multiply width and height, and then we multiply it with the bit depth. So what we have, this is the resolution 4096 by 2048, color depth is 16. So we multiply them and multiply them by the depth, so we get the total file size. This is the total file size we have got. Now we have to convert bits into byte. In order to convert bits into 1 byte, 1 byte equals to 8 bits, so we divide it by 8. And next we have to do, when we divide it by 8, we get this number of bytes. Now if we have to again next, we have already converted into bytes. Now we have to convert it into megabytes. This is a tricky part. In order to convert it into megabytes, let me tell you. Okay. In order to convert it into megabytes, what we have 1 kilobyte equal to 1024 bytes, and we have 1 megabytes equal to 1024 kilobytes. And what kilobyte equal to, when we call kilobyte, with kilobyte we mean 1024 bytes. So what we do, 1 megabyte equal to 1024 multiplied by 1024. Okay, so 1024 multiplied by 1024 gives us 1048,576. So this is how it gives us 1024 multiplied by 1024 gives us 1048,576. So we divide it by this, then we calculate our file size in megabytes, so that will make it 16 megabytes. So the size of the image becomes 16 megabytes. Surely. Now next, an audio CD uses 40960 samples per second, with 16 bits being used per sample. The music being sampled uses 2 channels to allow for stereo recordings. Calculate the file size for a 1024 second recording and give your answer in megabytes. Okay, let's say audio CD file size says samples per second equal to this 40960, bits per sample equal to 16, channels 2, and duration equals to 1024 seconds. Now, in order to calculate the samples for one channel, 4096 is what our samples per second, and multiply by 1024, basically what we have 40960 samples. When we multiply it by 1024 is our time, is our duration in second. So total number of samples, we calculate sample in each second. So total number of samples become what? 419,43040. We multiply the samples per second. We are taking 40960 samples per second, and when we multiply it by the total duration of the video, we get this number of samples. Calculate the total bits for one channel. In order to calculate the total bits for one channel, for one channel we have this thing, and for one channel we have to calculate the total bits. What we have done, bits per sample, we multiply it with that, so we get what? Total bits for one channel. Since there are 2 channels, what we do, we should multiply it by 2. So we multiply this thing by 2, we get these number of bits. Next, again we have to convert bits into byte, we divide it by 8. Then to convert bits into megabytes, we divide it by 1024 multiply by 1024. That gives us the answer this, and we get the final answer 160 MB. Give 3 reasons why is it often necessary to reduce the size of a file. Because these are the 3 benefits: is storage savings, reducing file size saves disk space, faster transfer. This way, of course, smaller files can transfer faster over the network or over any other devices. Bandwidth efficiency, reducing the file size decreases the amount of data transferred, which can help avoid exceeding bandwidth limit. Bandwidth is basically the capacity for our medium to transmit our data. So with lower size, obviously the lower capacity will be required for over communication. So this is why bandwidth will be efficient. Difference between lossy basically removes the data permanently, and lossless data can when we do lossless compression, our data can be reconstructed fully. These are the examples for lossy file compression: JPEG images or MP3 for audio. For them we use lossy compression, and losses, like we have the zip files or PNG for image files, we can have their data is basically lossless. The better example is zip files. Explain the following in terms of representing bitmap images: color depth, image, and resolution. Color depth refers to the number of bits used to represent the color of each pixel. Basically, color depth is for one dot. One pixel is basically one dot of our screen, and how many colors that dot can represent, that is basically our color depth. Color depth is the number of colors, you can say simply. Image resolution. Images is basically width multiplied by height. Number of pixels in an image, typically expressed as width multiplied by height. Difference between ASCII and Unicode, we have already studied that it is basically both are encoding standards, and ASCII is 128 or 256 bits, and that 256 characters, and 7 to 8 bits it contains, and its limit is it is limited to specific letters or symbols. Unicode has numerous languages and the letters of emojis and other symbols. It has 149,000 different characters. Next is run length encoding. Run length encoding is basically a form of lossless compression where sequences of same data values are stored as a single value. What we do the count. For example, we have 7 A's, we can store them as 7A or A7, that A is repeated 7 times, or it's effective when data contains many repeated values but less useful for more complex. What is meant by a bit? A bit is the smallest unit of data. We all know that we represent it by 0 and 1 to represent, it is used to represent digital data, and all the numbers, characters, alphabets, we represent them using number of bits. We use a number of bits like 8, 16, 32, 64, as many bits that are necessary. Give 2 reasons why computers use binary numbers rather than decimal numbers. Computers use binary numbers because the binary is basically simple circuitry. It has switches. Computer has so many millions of switches, and switches are what happens. What we do to the switches, we turn them off or turn them on. 0 represents off, 1 represents on. That is that simple as that. And plus another is a binary number system is more reliable for representing data electronically because it has only 2 states. Okay, now we have data compression. File compression is necessary to save storage space on devices and decrease the time needed to stream music or videos. This is the benefit of the data compression. Speed up file upload, minimize network bandwidth, leading to faster reduced costs such as cloud storage fees and ISP internet service provider charges, and compressed files contain fewer bits of data. Of course, we are always paying for the streaming that we are getting, so for that we get lower charges if we compress the data and upload that. And lossy file compression, we have already studied that it removes it removes permanently the unnecessary data. Image loses resolution or color depth. Sound files lower sampling rate or resolution. And benefits include smaller file size, faster data transfer, and examples are MP3 that reduces music files by about 90%, MP4 compresses multimedia files, music, videos, photos, and JPEG compresses image files by discarding different color variations. It discards different color variations and still maintains the visual quality. Another case here given, a software developer is using a microphone to collect various sounds for his game. He is also using a sound editing app. When collecting sounds, the software developer can decide on the sampling resolution he wishes to use. Describe any file compression technique the developer may use. A developer can use either lossy or lossless. Lossless means permanently remove some sound quality. Sound quality may be lost, but it will permanently reduce the file size. And lossless is basically, these are the 2 methods he can use. These are 2 file compression. Lossless means data is not lost lost completely. So a software developer microphone, when collecting sounds, the software developer can decide on the sampling resolution he wishes to use. He can decide whatever he wishes, so he can choose either of the 2 compression techniques. Why one is useful? Lossy is useful when some quality can be compromised and where perfect sound is not required. But lossless is used when the high quality needs to be maintained and in cases where high fidelity sound is necessary. High fidelity, you can call it high quality sound. The editor of a movie is finalizing the music score. He will send the file versions of his score to the movie producer by email. The music sound clips need to undergo some form of data compression before the music editor can send them via email. Of course, to send any file, he needs to do some kind of compression. What compression he should use? He should use lossless compression, because uh, music file can be fully reconstructed and there will be no degradation, and the professional will exactly know what to do, and there will be basically symmetry between you and your editor, the music sound. And next, lossy, while creating smaller files, sacrifices some quality which could affect the final sound movie. Therefore, lossless is better in this choice. So what we do here, this is a question given. We have described both types of compressions, and after describing the types of compression, what we have done, we have simply explained what is better. Of course, lossless is better in this case. Next thing is what is meant by run length encoding. We have already studied that run length encoding is basically kind of a lossless file encryption method. The following image is being developed. Now if we have to do the lossless compression, what we do, we can simply do it by using, you can say, we have 3 grays, you can call it, let's call it black, 3 gray, and 3 gray, or we say 3B, then we have 2W, then we have again 4B, then we have large number of basically 8, these are the 4, 3, 7 and 2, 9, then we have what, 9W, then again we have what, 9 plus 4B, we get 4B, and with 4B we get another 2W, then 2W, then 1B, then we have 2W again, we have again 2B, 2W, then again 1B. Now if we count this, how much we have reduced the file size. Let's see the original file size. This is 8 and 4. It is basically what, 32 bytes you can call it. Now our new file size will be what, let's see, 3B, let's say this is 1 character and this is 1 character, 2 bytes, then another 2 4, 2 8, 2 10, then 2 12, 2 14, 2 16, 2 18, 2 20, 2 22, 2 24. So okay, we have reduced the file size up to 24. 32 bytes is reduced to 24. Let's count it again. 2 plus 2 4, 4 plus 2 6, plus 2 8, plus 2 10, plus 2 12, plus 2 14, plus 2 16, plus 2 18, plus 2 20, plus 2 22. So we have reduced it to 22 bytes. So write down the data you would expect to see in RLE compressed format. So this is the data that we'll be expecting in the compressed format. You may assume that the gray square have a code value 0 and the white square have a code value 1. Okay, for the gray it is using 0. We can use all the B's as, we can replace all the B's with 0 and W with 1. So this is how we can fix it. Okay, I think that's it for this class. Oh, there is a little more. Yes, there are 2 more slides. Let's do them as well. Nancy wants to email photos to Nadia. Many of the photos are very large, so Nancy needs to reduce their file size as much as possible. Identify which of file compression would be most suitable for Nancy to use. Explain your choice. Nancy should use lossy compression to reduce the file sizes of the photos before sending them via email. Lossy compression reduces file size significantly by removing some of the less noticeable areas such as subcolor variation. This results in much smaller file sizes compared to lossless. okay, which is important for emailing large files. While some image quality is lost, lossy compression still retains an acceptable quality, and therefore the purpose of reducing file size as much as possible without noticeably affecting lossy compression is better. Okay, I think it should have described the lossless compression as well, but it's fine. Nancy wants to email photos. Many of the photos are very large, so Nancy needs to reduce their file size as much as possible. Of course, for that, if we have to reduce the file size by our choice, then of course lossy is the best option. But lossless does not happen with our choice. It specifically does do something, some values. It does not remove data, all values, because we have to reconstruct the whole data again. John wants to store 400 photographs in a folder. Each photograph is 10 kilobyte in size. Name one way of reducing the size of this file. Give two advantages of reducing the size of his photography files. Give one disadvantage of reducing file using the method named in part B1. Let me see what method. Okay, I haven't checked it. Let's see. Okay. The first part. One way to reduce the file size is by using lossy compression, converting them into JPG formats. Two advantages of reducing the size of his photography is save storage space and faster file transfer. One disadvantage using lossy compression. Yes, in the part B we studied about lossy compression. So with lossy we may lose some quality and of course clarity, so that may affect our photographs. That's it for this lecture. I think we are done with the lecture first chapter, and if you have studied that, for sure you will get great marks in your exams if you have followed the whole videos. Thank you.